Hello everyone to 2025 Advent of Code um, on day one, which is called a secret entrance. So for those who are not familiar, Advent of Code is a yearly quote unquote competition or yearly event where you get tasks each day in December, or in this case, for the next 12 days in December, from December 1st to December 12th, and you basically have to solve a puzzle you are given. So for today's puzzle, we have a puzzle called Secret Entrance. So it basically goes, you arrive at the secret entrance to the North Pole, base ready to start decorating. Unfortunately, the password seems to have been changed, so you can get in. A document taped to the wall helpfully explains. Due to the new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The safe has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches the number. The attached document, your puzzle input, contains a sequence of rotations, one per line, which tell you how to open the safe. A rotation starts with a left or right, L or R respectively, which indicates whether the rotation should be to the left towards the lower numbers or to the right towards the higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So one of the examples is here, R8, and if we are pointing at, if we start at number 11 on our dial, and after rotating it to the 8 towards the higher number, we would have 11 plus 8, which is 19. So for an example of what the dial is basically, it's basically this clock, not clock, a small safe lock that basically has a dial of numbers where inputting a correct code opens the lock. In this case, rotating towards the left goes to the higher, to the right goes to the lower, but this is just an example. So here we always start with an example input, and here is the example explanation on how it is done. But before that, we need to figure out what our goal is, and that is the dial starts by pointing at number 50 on our dial, and the actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. So what does this mean? After we have done a rotation, if after that rotation we are number 0, we basically increment the or add to the sum of the how many times we have seen the number 0. So here's an explanation of this output, this example, how it goes, and we can see here that it has like a 1, 2, 3 zeros at the respective instructions, and the password in this example is 3. So that's the explanation of the puzzle, or well, at least how it goes. Next up, I want to basically show how that would look descriptively. Not descriptively, how it would look like on a more visual example. So as we see here, we have an example that I made up: L5, R7, R1, and L12. So we will and I made here like a small example of a dial, which is really simple because it goes from 0 to 10, not to 0 to 99, for the sake of keeping it simple. So let's say we start from the number 5, since it's like right in the middle. So let me just create an arrowhead so we can point. Now, what we need to do is the following. When we apply this function, we will go towards the lower number, which is to the left. So we will do that by moving 5 times for the direction we are currently at. So we move to the left, whoops, we move to the left, and then we move for this much. So we go 1, 2, 3, 4, 5, and we end up with 0. So our initial start was n0. So I'm gonna call this scene zeros. Zeros is 0, but since we started from 5 and applying this first operation, we ended up on 0, we can increment it by 1. Now we have a right 7, which is going to be 1, 2, 3, 4, 5, 6, 7. We end up on 7, we are not on a 0, so we continue. We have another instruction which is R1, we end up on 8, which also again isn't a 0, so we basically continue. And now we have left 12. So we go 1, 2, 3, 4, 5, 6, 7, 8. Now, since we finish, since it's a dial, it goes into a circle, we go 9, 10, 11, 12. Now we finish, end up on 7, and we passed a 0, but we didn't end up on it. So we are still on 1. So our final answer is basically this. Now, one thing you might have noticed is we have used we went, when we were on a 7, we went 1, 2, 3, 4, 5, 6, 7, and we went right here. We basically made a circle. Now in programming, we can use something basically that is called a modular arithmetic, and in programming, that is always modular arithmetic is always done with an operation of a percentage sign, or so-called modulo. Basically, modular arithmetic is like a arithmetic operation for numbers where they wrap around, where numbers wrap around when we reach a certain value. So, for example, we can take a 12-digit clock. If we are like on 10 hours, and so if you're like on 10 hours, oh, the fill, just a second, let me handle that. Yes, okay, we're on 10, we add 5. We cannot have 15 since we are on 12 hour. We are basically gonna wrap around that 12, and we are gonna end up on 3. And how is that applied how would that look in programming? Basically, we would type in 15, our value, which is modulus of 12, and since 15, so basically modulus goes like this: 15 divided by this number, and we get some certain value, which in this case would be 1, because 12 goes into 15 only once, and the remainder up to the 15 is what the modulus operation returns. So in this case, 15 modulus of 12 would equal to 1, and the remainder of it would equal to 3. So that's this 3 we get here. Yeah. So let's get right into coding. I will be using a Python as my programming language because it's the most comfortable one to me. So yeah, and logic should basically be the same for every other language, so there shouldn't be any problems. I will start with defining a variable, sin the zeros, which is going to equal to 0. This is the variable we have seen in the visualization that will basically keep a track of how many times the 0 has appeared on a log in the position where we are pointing towards it. And I will keep a current dial value, which starts at 50, as we have seen on the advent of code task itself. Now I keep all of my inputs in separate files. I keep here as an example input. I cannot show my input because it's against the rules, but well, not against the rules, but it's a wish from the developer of the advent of quotes to not share the input, so I won't do that. But basically I keep here my input example and here the main input. And first we'll be working on the input, and then we'll be working on example input, then we'll be working on the main input. So we will start by opening up our file, which is done with the open in Python with open as f. F basically meaning as a file, but I have always wrote it as f, so yeah. And since this operation always reads everything as line by line, we can basically immediately go through each line inside our file. I will name this dial for dial instruction in F. So our dial instruction is basically our line. Now we need to figure out how we can split this in like a direction and a rotation value. And in Python that is pretty straightforward. I can do I can define two variables like this, and then I can give them each own value. I can dial instruction on a value on a index 0, and dial instruction from index 1, then everything that comes afterwards. So we start from the left, which is on L in this case, which is our index 0, and then from index 1 to the end we basically capture everything, and so that will be our rotation value. Now we need to do something with those values, and for that I will create a new function that will be called def rotate dial, which will accept a direction, a value to rotate, and a current dial value. Defining this, now we can start writing our function, and we will create a new variable that is going to be called new dial value that will hold our current dial value, and then we will be modifying this variable as we go. Now we need to know, based on the direction, what we need to do. We need to remember that if the direction is left, we are going towards the lower numbers, while the direction is right, we are going towards the higher numbers. So basically, while we take the current dial value, and if the direction is left, we basically subtract the value of rotation, and if it's right, we add to it. So let's do that. If direction is left, then we do new dial value equals current dial value minus value to rotate, else new dial value equals current dial value plus value to rotate. But this isn't done. Let me just return the new dial value. This isn't done though. This doesn't cover the rotation, the modular arithmetic part of our logic. So we know that our dial goes from 0 to 99. Basically it has 100 values. So 100 is going to be our upper bound. So both of these values, we will basically apply modulo of 100 on top of them. And then we can start actually writing here our logic. We will take our we will change our current dial value based on the result from the rotate dial, because this current dial value holds our, well, current value. So we will pass it a dial direction, we will pass it a rotation value, and I'm gonna cast it to integer, and then we will pass in a current dial value. And the only left part that is done to see if our current dial value is equal to 0, and if it is, we do it like that. I almost started writing JavaScript code because of work, but that's fine. And then we can just print, and I'm gonna make it nicer. I'm gonna name this part 1, and we're gonna type in sin zeros. So if I do, if I run this code now, python -u, which is gonna be day underscore 1.py, we should get our solution. Oops, I didn't close the brackets. Day underscore 1.py. No such file or directory. Why is it that? Because I'm not in my folder, and now I do, and we get a tree, and that is the example. That is the example answer. And now we can run this against my real input, and we should get a value 969. And if we go check, my answer 969 is the correct answer. Now we will start with a part 2. Finishing part 1, we always unlock a part 2, which is usually a harder subset of the previous problem. And this one, I'm not gonna lie, gave me a bit of a trouble, but we'll see why that is. So first, let's go through the problem. Due to the newer security protocols, please use password method 0x43 until further notice. You remember from the training seminar that the method 0x43 means you're actually supposed to count the number of times any click causes the dial to point at 0, regardless of whether it happens during a rotation or at the end of one. Following the same rotations as in the above example, the dial points at a 0 a few extra times during its rotation. The dial starts by pointing at 50, the dial is rotated by this amount, points at 82, and during this rotation it points at 0 once. The dial is rotated by 30 to point at 52, we don't point at 0 at any moment, then dial is rotated at 48 to point at 0, so this is where we are now currently. The dial is rotated L5 to point at 95, etc, etc. And in this example, the new password value would be 6. Here they also give us a hint. If the dial were pointing at 50, a single rotation like R1000 would cause the dial to point at 0 10 times before returning back to 50. And then the question is, using password method, what is the password to open the door? So let's start with our part 2. I will create a variable called pointed at 0, which is gonna be equal to, well, 0 initially. And this will be used to hold our count of how many times we have passed or landed on a number 0, or in this case just passed number 0. We will adapt our existing rotate dial function to handle that logic as well. So let's continue. I will create a variable here pointed or sin 0 that will, for this current instruction, hold how many times we have well pointed or seen number 0. And now I realize that this sin zeros is a kind of a dumb name, but that's fine. I will also move this modulus operation down here to the return value, just to keep things, just not to repeat things. I will start with the right side, right direction first, because it's much simpler. And how basically we will do is we do pointed or sin0 is gonna be equal to the new dial value and floor division of 100. Now, why are we using the floor division? Because it returns a quotient of the, instead of a remainder like modulus of how many rotations we have done. So, for example, if we have R1000 and we divide it by 100, that will give us 10 rotations like we have seen in an example, and etc, etc. And we use floor division just to get a whole integer number, not a floating point number. Now on a left side we will also handle a specific logic that stumped me a bit at the beginning, because I spent like 3 or 4 tries figuring out why my solution, or well, password wasn't working, but I managed to figure it out in the end. So what happened was we had we have to account for starting from zero, from starting on zero, and we will do that by doing a starting value, and we will use 100 since we have 100 values if our current dial is set to 0. Otherwise we will use the current dial value that is there. And instead here of a new dial value using the current dial value, we will be using a starting value. And now to get how many laps we have done, we will do pointed or sin0 will equal to the new dial value of minus 1 divided by 100. This I cannot really explain completely, because this is the part that also stumped me, but I believe it's to account for ending on a 0, to not count that lap inside, not a lap, that 0 inside our count. And now, since there is one more thing we need to do, since this can be negative, we will wrap it with an abs, which returns the absolute value of the provided argument, in this case the provided number operation, and we will do the same here. Or actually, to keep it again not repeating, when I'm returning I will do abs of pointed or sin0. I will come here, and since we can do that, I will just since we're returning a tuple here, I will deconstruct it into this variable, and I will do pointed at 0 plus equals pointed or sin0. And now we just and I will just print the value to see if this is correct, and I will do this, and 5887 should be our main solution, which is right here. So that's it. I hope you guys enjoy this video. This is the first time I'm doing something like this, so if you have any feedback, I would like to know. And yeah, until then, until tomorrow, have a safe and nice day, and peace.